Objective. Deduce how resistance changes in a current voltage graph with a constant gradient. First, let's read the graph. This graph shows how the current flowing through the conductor changes with the potential difference across it. To make the explanation simpler, I will use the term I for current, V for potential difference, and R for resistance. From the graph, when V is equal to 1 volt, I is equal to 2 amperes. When V is equal to 2 volts, I is equal to 4 amperes. When V is equal to 3 volts, I is equal to 6 amperes. Remember, the resistance of the conductor is the ratio of the potential difference to the current flowing through it. Focus on the term ratio. There is no need to calculate the gradient here. The gradient helps us qualitatively understand how the resistance changes. Let's use specific examples to make this clearer. When V is 1 volt and I is 2 amperes, R can be found by dividing 1 volt by 2 amperes, which gives 0.5 ohms. When V is 3 volts and I is 6 amperes, R is calculated by dividing 3 volts by 6 amperes, which also gives 0.5 ohms. To summarize, when V is 1 volt, R is 0.5 ohms. When V is 3 volts, R is still 0.5 ohms. So as V increases from 1 volt to 3 volts, R remains constant at 0.5 ohms. Therefore, for an IV graph that is a straight line passing through the origin, the resistance of the conductor is constant for all values of V.